Okay, our camera is rolling. So hello class. Yeah, we're here to talk to you about a few things machine learning and also introduce the teaching staff. I'm Lexing, the lecturer of this course. With me here are Alexander Soen and Josh Ng, who will both be tutoring some of you. So we're going to ask about 4 questions. So first things first, basically can you say, each of you say a few words about yourself and what are you working on? Well, maybe starting from Alex.
All right, so I'm Alex. I'm a first year PhD student now, so 1 year just elapsed. And I mainly work in machine learning for fairness and also looking at the geometry of things. And I guess before that, I was also an undergraduate at ANU doing computer science.
Cool.
Thanks.
I'm Josh, and I just started my 2nd year MPhil at ANU, and Lexing is also my supervisor. And I'm working on a project on computational social science. We're looking at online moral dilemmas on social media.
Right. Thank you both. So the next question is, what's your favorite machine learning algorithm? Josh?
My favorite machine learning algorithm, I'm not sure if it's really machine learning, but in probability theory, we have this notion of quantifying the distance between 2 probability distributions called the Wasserstein distance. So that relates to a theory called optimal transport. And there's an algorithm in there called the Singhorn algorithm, which is very interesting from a theoretical point of view and also from an optimization point of view. And I probably shouldn't go too much into the detail of that algorithm, but that's some of the very interesting things that excite me.
Thanks, Josh. The boundary of machine learning is indeed fluid, as you remarked. So, Alex?
Sure. I guess I'll do something similar with Josh. I won't say an algorithm, but I'll describe like a concept, which I think students will hopefully become a bit more familiar after completing assignment 1. So I'm going to talk a bit about exponential family distributions. So this is a type of statistical distribution which kind of looks really complicated, but is actually a really nice generalization of many of the distributions that you've seen before. So like normal distributions and even stuff like binomial and Poisson distributions. It tends to be very nice theoretically and also provides a very nice framework that's quite elegant once you look past a lot of the math details. So hopefully you'll see that once you complete assignment 1.
Thanks, Alex, and also for the plug for assignment 1. Moving on, right? So what advice would you give SML students for this class or for people trying to learn machine learning from your past experience as student or tutor or researcher yourselves? Let's start from Alex.
I guess my general advice to learning things in machine learning and maybe things in general is to try and look at it from as many perspectives as you can, because since everyone's different, you might like one way or one explanation might not always click. So it's always nice to see how the same concept gets explained in different ways. And also alongside that, you kind of need time to understand things. So even if you don't get things straight away, make sure you give yourself like a bit of period of time to kind of let it kind of simmer in the back of your head in these different perspectives. And I think that's like the general advice that I would give to people.
Thanks, Alex. Yes, mathematics and SML is not fast food in terms of technical content. Josh?
I think I agree with Alex in the sense that when I learn a machine learning technique, there's multiple layers of understanding of each algorithm. And the more I learn, the more I realize that, oh, there are so many interesting things within that I don't know before. And it turns out that lots of the deeper understanding of these algorithms relate to the things that we've done before from multiple perspectives, mathematics, economics, and so on. And so I agree with Alex that looking at it from different perspectives is interesting. Another advice I probably can give is that try to program a lot, because that's how you understand both the theoretical part of machine learning, but also how to implement it, because there can be quite a bit of challenge when transitioning from one to another.
Yeah, thanks, Josh. Right, and for the plug for the tutorial content. Indeed, one, I think, salient feature of this class is to explicitly talk about the connections among different models rather than think about a machine learning algorithms as here is neural network and here's SVM and so on. Right, so we'll talk about that early on in the lecture as well. Our final question is basically some general observation about like the big picture of machine learning. What are some misconceptions people have? What are something that people should know but not like widely known? Maybe Josh make a start?
Oh, okay. So I'm not sure if this is a misconception, but it's certainly a common sentiment among a lot of people using machine learning or learning machine learning for the first time. It is that you treat fancy models as black boxes without really understanding what they do. From a beginner's point of view, that's fine. But as you go further in your degree and in your career, you find out that there's a lot of downstream effects to these very fancy models. And if you don't understand them fully, there might be a lot of consequences along the way. And so I think a misconception here is probably that you should use a machine learning model without understanding the theory behind it. And I think people should, at least to some extent.
Thanks. After this class, hopefully people will
Yeah.
and have acquired ability to understand new black boxes.
Yep.
Thanks, Alex.
Yeah, I definitely agree with Josh. I guess maybe something similar, but maybe just tangentially related, is that modern machine learning isn't just neural networks and deep learning. It's probably one misconception that I'd like to clarify. It tends to be that, I guess, a lot of the news highlights or like headlines is a lot on neural networks and deep learning, but there's also a whole other zoo of different methods, which sometimes have stronger theoretic guarantees. So they might be more suited for different tasks depending on what you're actually trying to achieve. So it's best not to just discount these methods because they're not really the hot flavor of the month.
Thank you so much, Alex. And that's one reason we're using this textbook from 2006 that covers many of the timeless and models and foundations. Right. I think that is it. I hope some of the class will watch this up until this point, and I'm just gonna stop the recording.